Good morning. Good morning. Hope all is well. Hope everything's all right. Looks like everybody is in. So let's get ready to finish off what we started last class. And then we'll talk about where we go from there. So we did the horizontal line test. Yeah. So we're still in 2.7. And last thing we did was the horizontal line test. So now we're looking at closing out that section by finding the inverse. Where's my pen? Sorry, I had to find my pen. So we have a few steps here. First thing we want to do is check to see if the function is one-to-one. If it's not one-to-one, then there is no inverse. So there's no more work for you to do. If you recognize or find out that it's not one-to-one, then you don't have to do any more work. Just say there is no inverse or the function is one-to-one. They'll tell you, they'll give you your options. But if it is one-to-one, we can replace f of x with y. Because remember, those two mean the same thing. Then we'll interchange x and y. Solve for y. And then replace y with f inverse of x. Because what we have right there would be our inverse. All right, scrolling up. So the first one, x cubed plus 1, f of x is equal to x cubed plus 1. First thing we want to do is establish whether the function is one-to-one or not. And if you were to graph that, use a horizontal line test, the quickest way to do it. And you'll see that no matter where you draw a horizontal line, it was only going to touch it once. So that means it is one-to-one. So that means there is an inverse to calculate or find. Everyone done with the steps? All right. So the first step, that's what, establish whether the function is one-to-one. Second step is to replace f of x with y. So notice it's the same function, it's just that we put y there instead of f of x. Third step is interchange x and y. So we just switch the roles. So it was y equal to x cubed plus 1. Now it's x equal to y cubed plus 1. So we just interchange x and y. Then step 4, we need to solve for y. So subtracting 1 from both sides gives me x minus 1 equal to y cubed. Then get the cube off of y by taking the cube root of both sides. And that gives me y equal to the cube root of x minus 1. All right. Any problems? Any problems? And then we finish it off by replacing y with f inverse of x. So that's just notation. All right, questions, any problems? All right, can I scroll up? By holding on to step 4. All right, the next one, x squared plus 3x minus 5 is our function. If we were to graph that, we see we would have a parabola. And if we do the horizontal line test, the function is not 1-to-1. So there's no inverse. And so that would be your answer there. There is no inverse. Now, the reason being, and just show it right here. Now, you don't have to actually validate, anything like that. The reason being is because if you were to invert that in a way that it would have the inverse, it wouldn't pass the vertical line test. Because if it doesn't pass the horizontal line test when you treat it as an inverse, then it's not going to pass the vertical line test. And remember, the vertical line test is the actual test that validates whether you have a function or not. So that's why that occurs. So if it doesn't pass the horizontal line test, that means it will not pass the vertical line test. That's why there's no inverse for those who do not pass the horizontal line test.
Mr. Tucker, I just wanted to verify it's okay. So we would just plug this equation into the calculator and see the graph. Like we're not going to have to show the graph portion of this, right?
Right. That's fine.
Okay.
Mm-hmm. All right. Any problems? We're gonna do at least one more, and then we'll be done with this. All right, can you scroll up? All right, so for the next one, f of x is equal to x plus 2 over x minus 3. So this function is 1-to-1 as well. So I gave a rough sketch of it right here in this green circle. It have an asymptote at x minus 3. This little line. Have we talked about asymptotes yet? I think that's chapter 3. But anyway, have this little spot at x minus 3. Well, equal to 3, excuse me, where it'll go up and not cross. But it's still, the horizontal line test still will hold true. So this function is 1-to-1, and we'll follow all of the steps. So first thing we do, after we've established that it's 1-to-1, replace y with f of x. Then we interchange x and y. So notice x is over here now and y is right here in both places that x was. All right, and then we solve for y. Now we need to get y minus 3 out of the denominator. So we will multiply both sides by y minus 3. So that's what I did right here. So that cancels out the y minus 3 in the denominator over here, leaving you with just y plus 2. Then on the left, we have x times y minus 3. Then we'll distribute x. So it's xy. Oh, let me erase this. So distribute x, that'll give you xy minus 3x equal to y plus 2. Now we have y in two different places. So our goal should be to get all of our terms with y to one side, all of our terms without y to the other. And it doesn't matter which way you decide to go. I'm going to subtract xy from both sides and subtract 2 from both sides. Cancels out here, cancels out here, and gives us this result. All right, so we're going to factor out y. Now that we have each term with y on one side of the equation, we'll factor out y. So we have a single y. And then we can divide both sides by 1 minus x. Questions on that? Any questions on that? All right. So the final step is to substitute f inverse of x for y. All right. Any problems with that before we go to the next thing? Pretty good. All right, so 2.8, last section in chapter 2. We're looking at distance, midpoint, and circles. Everybody done with that last problem? All right. So the first formula we're going to look at is the distance formula. Square root of x2 minus x1 squared plus y2 minus y1 squared. So D is going to represent the distance between the 2 points. And so x1, y1 is the coordinates of point 1, x2, y2 coordinates of point 2. All right, showing up. So they could ask us to find the distance between the points -1, 4 and 3, -2. Whenever you're given 2 points, always good to go ahead and establish which one you call a point 1, which one you call a point 2. Mhm. All right, so once you've established that, you go ahead and plug in. So x2 is 3 for us. X1 is -1. Make sure you don't lose a negative. Y2 is -2. Y1 is 4. So we have 3 minus -1 squared, -2 minus 4 squared. So that's 4 squared plus -6 squared under this radical. $16 plus 36 is 52. And simplify if possible. And we talked about that before, looking at the factors of your number, seeing if any of them can be taken the square root of, or any one of them is a perfect square. So we have 4 times 13 in this case. Take the square root of 4, it's 2. Leave the 13 under the radical. And that'll be your most simplified way of expressing the distance between 2 points. Any problems, any problems? And scroll up. Okay, midpoint formula, the point that's in the middle of 2 points. So this is actually a point, not just a solid number. So we're talking about the coordinates of the point that is between the 2 points that we're looking at. Anybody holding on to the red? All right. So we're going to find the midpoint of the endpoints 1, -6, -8, -4. So once again, we are establishing which point we're calling it point 1, which one we call point 2. Then we'll plug into the formula of x1 plus x2 over 2 for the first coordinate, y1 plus y2 over 2 for the second part of our coordinates. This is the second coordinate. Second component of our coordinates. There we go. Second component. All right, everybody done with the formula? So I'll plug them in accordingly. That's y1, which is 1, plus y2, which is -8. I said y2, x2, which is -8. Then y1, which is -6, plus y2, which is -4. So x1 plus x2, y1 plus y2, each one of those are over 2. So 1 and -8 will give you -7. -6, -4 will give you -10. You can simplify the -10 over 2 to -5. And that will be your coordinates.
Hey, Mr. Tucker.
Mhm.
Do you have the x1 and y1 in the wrong place at the top? 1 and -6, or am I wrong?
Let me look at, you said right here?
Yeah, because
Let me see.
isn't the first point 1 and -6, or
Yeah, so you saying here to here?
yeah, so
Huh?
oh, okay. I think I was just missing something. I'm sorry, I get it.
Oh, okay, yeah, no
Yeah,
problem.
okay.
All right, cool. All right, just making sure, because I look, man, I could have wrote it wrong. I didn't understand. So yeah, most definitely make sure I'm
Yeah,
straight.
no, I was just asking. I didn't think you were wrong, but I was just making sure.
Not a problem. Anybody else? Everybody good before we look at the last thing out of 2-8, circles? All right. So we got a little definition when it comes to circles, just to make sure we're clear on what it mathematically means. So definition is the set of all points in the plane that are equidistant from a fixed point, and that fixed point is called the center. The fixed distance from the circle's center to any point on the circle is called the radius. It's r. All right, so the standard form of the equation of a circle is going to be x minus h squared plus y minus k squared equal to r squared. And if I scroll up too far, let me know. Where your center, the coordinates of your center will be hk, and your radius is just the r. And notice the purple circle, you use the opposite signs. In the formula, it's x minus h and y minus k. But for the center, it's positive h and positive k. So whatever sign is in your equation, you actually use that opposite sign for your coordinate. All right, scroll up. So we want to write the standard form of the equation of the circle with the center of -2, 3 and radius 4. All right, we're done with the formula. All right, so HK is going to be -2, 3, and R is going to be 4. So we plug in -2, 3, and 4 into the formula. So that's x plus 2 squared, y minus 3 squared, and 16. So that's all they're asking for you. All they're asking of you for this equation. I mean, this problem. All right, let's scroll up. And the next one that is the reversal of what we just did. They give us the equation in standard form and then ask us to find the center of the radius. And then we can draw a rough sketch. Everybody done with the last one? Okay, so we can pick out our center and our radius. Remember, I mentioned already before that the center is going to have the opposite coordinates of what's in the equation. So we have x minus 2 and y plus 4. So my coordinates of my center should be +2 and -4. So that will always be the case. That's because there are minus signs in the actual formula for that equation. Then whatever you see for r, you take the square root of that, and that will be your radius. So we had 9, take the square root of 9, that is 3. So that is our radius. Any problems? All right, so to do a rough sketch, all you would do is graph the center and then go 3 this direction, 3 this direction, 3 this direction, and 3 this direction. 3 for your radius. And that will give you a rough sketch. Then you just go ahead and make your circle. So you graph 2, -4, and then once again, go out 3 in each direction, have your 4 points, and just make your circle. Questions? Any questions? I'm just trying to put some directions on it. So you grab your center and first, and then go out from the center, the radius in the 4 major directions. Go down, left, right. All right, any questions on that before we do one last thing? So we have the general form of the equation of a circle. Am I okay to scroll up? Got x squared plus y squared plus dx plus ey plus f is equal to 0. So that's your general form. In other words, we take what we had initially. Let me see if I got it up here. Let me go up here. So you take this right here, you expand it out and bring the 9 over. So that's what the general form is. Notice that one side is equal to 0. So that's just expanding it out, simplify as much as possible, and bring that number on the right to the left. So that's your general form. All right, is everybody done with the last problem? So they give us a problem. This next exercise gives us a problem or an equation in general form and ask us to write it in standard form, and then give the center and radius. So we'll go through the steps on that. We have x squared plus y squared plus 4x minus 6y minus 23 equal to 0. First thing we want to do is isolate the constant. I don't know if they have steps like this in the book, so this is just me making up steps, but so we should be good with these. So if you go look, my point was, if you don't copy this and you go looking in the book, you might not find these steps. So all right, so we added 23 to both sides. Now we're going to group together the like variables. So bring your x terms together. Bring your y terms together. Make sure if anything's positive, it stays positive, and if anything's negative, that it stays negative. So notice my 6y is still minus 6y. 4x is still positive, and so on. So we're done with step 1. So next, we're going to use the completing the square methodology. We're going to take half of each linear term and square it. So we're talking about the 4 and the 6. We're going to take half of each one of those and square it. Oh, go back. Time to jump like that. Sorry. So half of 4 is 2. 2 squared is 4. Half of negative 6 is negative 3. Negative 3 squared is 9. All right, good. Of course, if I scroll up too far, let me know. So step 4, we're going to add both numbers to both sides of the equation. Remember, whatever you do to one side, you have to do to the other. So we're going to add both numbers to both sides of the equation. Then we're also going to put each number in their respective parentheses. So that's what we did right here. X squared plus 4x plus 4, y squared minus 6y plus 9. Then on the right, we have 23 plus 4 plus 9. Any questions? Any questions? So now we can factor those trinomials. Once again, goes back to completing the square. If you have any problems with your factoring, you know, whatever half your b term is what goes here. So that's why we have x plus 2, y minus 3. And then 23 plus 4 plus 9 would be 36. Excuse me. Once you've done that, you can pick out your radius and your center. Your center will have the coordinates of each opposite sign. So we had x plus 2. That's why we have negative 2 for our x, y minus 3, positive 3 for our y of our center. And then take 36, and the square root of that will be 6. So our radius will be 6. questions? Any questions? All right, everybody done copying? Before I scroll up. Very good. All right, let me do this. Trying to get to some open space. These are just, oh, here we go. So next class, let's see, today is Wednesday, so we're looking at Monday. October 4th. So next class will be open for you guys to ask whatever questions you want. I will not do anything new on Monday. So just throwing it out there for you guys to take advantage of. So maybe some questions will be generated over the weekend. Just like I mentioned before, when we were at this same spot with test 1, even if you haven't completed all your homework, nothing else, take a look at the review and see if there's just some questions that you want me to do that you may not even try yet, but you notice you're stuck on. You look at it, you don't even know where to start. But this will be the day for it. Next class. Now let's see, we need a due date for this stuff. So 3rd. So we'll be getting into chapter 3 next Wednesday. Tens. I'll put the 17th. I was gonna do the 10th, but I'll give you to the 17th to get chapter 2's content completed. So that test for chapter 2 is unproctored as well. So I guess we're looking at chapter 3 to be an actual proctor test. And we'll talk about how we'll handle that. But I'll let you knock out chapter 2 on your own. Just don't forget to shoot me that scratch work. All right. All right, so questions on anything that I said? Everybody good? Pretty straight? Any questions on anything? All right, so before I close out, once again, any questions on anything? Anybody have a problem? Anybody? Anything? Everybody good? Everybody straight?
You have office hours later today too, right?
Yep.
Okay.
Starting at 3, I'll be there.
Okay, I was there at 3 the other day, but I didn't catch you, I guess, so I had to leave. You hadn't started it. I was there till like 3:07 or something. So
and you said you had to leave. Okay.
Yeah.
Okay. Got you. Yeah, I think something happened with my daughter and I was running a few minutes behind that day. Yeah. But okay. But yeah, I'll be there today for sure. Yeah. All right. Anything else? Everybody good? Okay. All right. So that's it for today. We're done with chapter 2. Like I said, next class. Up to you how you want to handle that. I normally don't make those mandatory. So, in other words, if you don't have any questions and you don't want to hear anybody's questions, you don't have to, come through. It's up to you how you want to handle that. But I will be there to answer whatever questions you guys may have. Other than that, you guys have a great weekend. Be safe, and I will see you next class.
Thank you, Professor.
Thank you.
Thank you. Take care. Have a good one.
Thank you. Have a great weekend.
Thanks. Do the same.